On our last example here, we've got the picture given to us. And what we want to know is, based on the nature of the roots, is the quadratic function that it represents factoring? And first of all, as you take a look at this, what are the roots of this problem? Well, I'll put them in blue. It's going to be this point right here, and that point right there. It looks like that our roots are x equals 1, 2, 3, 4, and x equals to the left, so it's going to be -2. And those roots right there are integer answers, which means that we absolutely can factor. But what we don't have this time, we've got the picture. What we don't have is we don't have the equation for this problem. And that's what we want to finish up these notes with. We want to write the equation for this function. And it's going to go back to our factoring here. Once again, what we said is we said that x equals 4 and x equals -2. And what we want to do is we want to write this in factored form instead of as our solutions. So to write this in factored form, what we're going to do is we're going to subtract the 4 from both sides. And we get x minus 4. I don't want to put equals 0. I want to write it back into the factored form. How did we get the answer? It came from x minus 4. Do the same thing over here with the -2. We're going to add 2 to both sides. And when we do, we get x plus 2. And ultimately, if you look back at your problems, they either say y equals or they say 0 equals. In this case, I'm going to use y. And now what we're going to do is we're going to use FOIL, or sometimes your algebra teacher calls it the double distributive property. When we multiply, x times x is x squared. X times 2 is 2x. -4 times x is -4x. And -4 times 2 is -8. And then when we simplify, we get y equals x squared. Like terms here, 2 minus 4 is going to be -2. X minus 8. And if we wanted to be really sure that we got the answer correct, we could type that back into our calculator, and is it the same picture on our screen as what is on our graph?